Hello, welcome to Webinar 5, Cannabis Greenhouse Operations Manual, brought to you by Nexus Greenhouse Systems. At this time, we'd like to let you know about our next webinar, Cannabis Greenhouse Growing Methods for Production and Profitability, which is going to take place on July 26th at 4 p.m. Eastern and July 27th at 1 p.m. Eastern. I'm here with Paul Golden and Dave Weisensell. My name is David Laverty. We all work for Nexus. At the end of the seminar, we're going to answer questions via chat. So if you have any questions, please enter your question into the chat box, and we will get to it as quickly as possible at the end. If you have any further questions or you want to follow up on any item in the webinar, please call us at 720-330-0830. And you can also visit our website at nexuscann.com, nexuscan.com. So at this point, I'm going to turn it over to Paul, who's going to lead off the webinar.
Thank you, David. So just as a reminder, today's webinar is going to be basically covering the day-to-day operations of a cannabis greenhouse. Some of the points that we're going to discuss here today are going to be greenhouse operational modes and how equipment is being used, humidity control, setting up your computer controls, and the function of a warehouse space, as well as maintenance. So first, I'd like to go into the three fundamental modes of operation of a greenhouse. The first mode that most people think about when they think about greenhouses, because they think about the greenhouse effect, is cooling. First of all, cooling is usually a multi-stage mode where it ramps up and ramps down depending on the amount of cooling that's needed inside the greenhouse. It's typically based off of temperature and humidity. It can be done with mechanical ventilation or passive ventilation. In the case of mechanical ventilation, we use evaporative cooling methods to reduce the cost of cooling the greenhouse environment. And then also, we can use automated shade curtain systems to optimize the light levels and also reduce the amount of heat gain inside the greenhouse. The next mode of operation is heating. One of the fundamental reasons why people have greenhouses is so they can operate throughout the wintertime. Heating and dehumidifying kind of go hand in hand. Heating with ventilation is often used for dehumidification. It's the most common way of dehumidifying, and we'll go into great detail about this later on in the webinar. Then we have automated controls for supplemental lighting and CO2. These are important controls that are not so much to do with the climate inside the greenhouse, the temperature inside the greenhouse, but more to do with how you would operate the greenhouse in a closed environment. And then lastly, we have closing our shade curtains at nighttime in the heat mode, because this shade curtain also acts as a giant heat blanket for the greenhouse, helping keep the infrared heat back inside the greenhouse at nighttime when it otherwise would be radiated out. Next, we have venting and dehumidifying. Venting and dehumidifying is a very popular topic when it comes to cannabis greenhouses, so we're going to go into great detail about this, as I said. It's a combination of heating and exhausting air to purge out the moist air and bring in dry, cool air and bring up the temperature so it's ideal for the plants. It can be done both mechanically or passive, as we mentioned with all the other stages. And also, we have positive pressures or semi-closed options available, but these are obviously less common than the conventional greenhouse.
I'd like to add that these operational modes are geographic dependent. So a lot of it is going to be driven by the climate in your area, in the area of the country, whether it's a high humidity climate or a dry desert climate. So give special thought to the climate patterns in your specific location.
That's correct. So moving on to the very first mode of operation that we're going to talk about today is going to be cooling mode. And as we said, this is multi-stage, and it has everything to do with the environment that you're placing this greenhouse in, the climate that you're placing the greenhouse in. Most commonly with cannabis greenhouses, it's a three-stage process or possibly even a four-stage process where you have different fans turning on, different pieces of equipment turning on for each stage. If you look at the pictures down below, you can see I have numbers listed on different pieces of equipment. The first stage of cooling is typically ventilation, and this is oftentimes used for dehumidification. So you have two options for ventilation. You can either open up passive roof vents, or you can mechanically ventilate and really dial in that control pretty well. So typically it's a single exhaust fan. That's why we have number one labeled in the very middle of the house, with a single shutter on the opposite side of the house that allows you to bring in cool outdoor air, mix it, and exhaust the humid hot air in the greenhouse. Stage 2 works in conjunction with Stage 1 and turns on multiple fans, in this case 3 fans, Stage 1 fan plus the 2 Stage 2 fans off to the side shown on the picture below, as well as it opens up a larger vent for more airflow throughout the greenhouse. That larger vent's not shown in this picture, but it's behind the pad wall, which is labeled as Stage 3. Stage 3 turns on the pad wall, which allows you to get additional cooling beyond the outdoor temperature of the greenhouse. So when you're in a hot, dry environment or hot environment period, and let's say the outside temperature is 90 degrees outside and you want it to be 75 to 80 inside the greenhouse, the only way to gain that cooling beyond the outdoor temperature level is to turn on that pad wall system in conjunction with your fan. So that would be considered Stage 3 cooling. And then one other thing is that it's not necessarily a cooling stage because it's based off of light levels, but it does aid the cooling equipment, is we can also close our shade curtains, or in some cases blackout curtains, if you don't have shade curtains, to cool the greenhouse during the peak heat of the day. And this is typically done whenever light levels exceed 600 watts per meter squared, which is about 60% of maximum sun light power.
So just to reiterate then, very simply put, Stage 1 is the least amount of cooling in your greenhouse. Moving through to Stage 3 is the greatest amount of cooling in your greenhouse.
That's correct. So here's a representative diagram of how cooling takes place in the greenhouse. This is showing Stage 3 cooling using our pad wall system to achieve up to 80% what the wet bulb temperature would be. The wet bulb temperature is also dew point temperature. So how the greenhouse functions is typically you would bring in outdoor air through a screened intake, which is shown with the red arrows on the right-hand side of the diagram. It moves through the pad wall, where it's reduced in temperature, and moves out the exhaust fans on the other side of the house. So here's an example of how a pad wall system works. A pad wall system works best when you have a very low wet bulb temperature or very low dew point temperature. In this case, if we had a wet bulb temperature, dew point temperature of 70 degrees, and the dry bulb temperature, the perceivable temperature that you feel outside, is 100 degrees, our pad wall system is able to reach 80% the difference between those two numbers. So if you take 100 degrees Fahrenheit, you subtract 80% the difference between 100 and 70, which is 30, and you multiply that by 80%, that gives you 24 degrees. That's how you're able to achieve 76 degrees inside of a greenhouse on a 100-degree day under the proper conditions.
So I would just like to explain a little bit, maybe cover wet bulb and dry bulb and what that really means, just so people make sure they understand it. Dry bulb temperature is just an ordinary thermometer. Wet bulb temperature is actually a thermometer wrapped in wet gauze. And the difference between the two will tell you how easily water will evaporate into the air.
That's correct. It's an indicator of the amount of humidity that's in the air. Another way to look at that is by using a psychometric chart, which we show here in this diagram. The bottom axis, the x-axis, represents your dry bulb temperature. As Dave said, the temperature that your thermometer reads. The curved axis that's on the top of the chart represents the dew point, or where the relative humidity reaches 100%. This is the maximum theoretical amount of cooling you can get with an evaporative process. And as we mentioned, the pad wall system achieves about 80% what that maximum would be. So if it was 105 degrees outside and it was 18% relative humidity, we would follow a line up from the psychometric chart on the x-axis from 105 up to where the curved lines show 18%. Then you follow a straight line over to the wet bulb temperature, which is marked with different gradiated lines, and that tells you that the wet bulb temperature is 71 degrees Fahrenheit. So in this case, the maximum achievable temperature reduction inside the greenhouse would be 105 minus 71 multiplied by 0.8 or 80% to give you somewhere right there around 76 degrees. Here's another case example. In this case, we're in a much more humid environment, and the temperature is 80 degrees Fahrenheit outside and 60% relative humidity. That temperature is associated with a 71-degree wet bulb, which means we're only going to achieve about 7 or 8 degrees temperature drop between the outdoor air and the pad wall. So next I'd like to move on to heating in the winter as well as dehumidification. So typically speaking, a greenhouse is built with 2 different stages of heating. So you have some built-in redundancy inside the greenhouse in case one unit heater should fail or one mode of heating should fail, which is rare, but still you want to ensure your crop. Oftentimes that first stage of heating will be a unit heater, but if you're a larger facility, you'll have more commonly a centralized boiler system or a radiant heat system installed inside the greenhouse because it has higher efficiency. That's always the first means of heating. That's why it's stage 1, because it's the highest efficiency, and it's kind of what we consider your base load heating. Stage 2, most typically the second unit heater if you're a smaller operator, or a unit heater in conjunction with your radiant heat system inside the greenhouse if you're a larger operator. And here's some examples of the equipment that we use. It's also worth noting that stage 2 can also be fin tube heating, additional fin tube heating, aside from the grow area, maybe up above the grow area or underneath the gutter system, if you want to keep your entire heating system with with centralized boilers as opposed to unit heaters. So here's some examples from left to right of different equipment that's used for heating a greenhouse. We have a centralized boiler. You can see there's 2 of them there for redundancy. One runs the majority of the time. The other one picks up when the slack for the first one when it's not able to do the full heat load. And then we have the option of using radiant slab heat, which is pouring a concrete slab or sometimes even using just load base and then having radiant tubes go throughout that slab. This is most commonly used when you're growing on the floor. And then to the right a little bit more, we have an example of a rolling bench system. This one's had its covers removed, its tops removed, so you can see the radiant tubes underneath the bench traveling below the plants. And then lastly, we have an example of a unit heater, which is still one of the most common ways of heating the airspace, and it's very resilient.
I'd like to add that there's a productivity component here. By using radiant heat either under bench or in the slab, the root zone of the plant gets heated quicker and can contribute to plant growth that can have an impact on your overall crop yield.
And sometimes the choice of equipment is depending on the climate. Oftentimes if you're in a hotter climate and you're not going to have much demand for heat, you wouldn't install a large centralized boiler system. You'd probably use unit heaters just to supplement the amount of heating that you need the worst time of the year. However, if you're in a very cold climate, you're going to most likely want a very efficient system like a centralized boiler because you're going to run that system a lot.
The other thing with heating, keep in mind, is it's always good to have redundancy in case one of the systems fails.
Now I'd like to discuss a little bit about winter dehumidification and what this means in the greenhouse environment. So we're going to return to our psychometric chart that we used earlier today for determining cooling capacity, but this time we're going to show what the dehumidification capacity is of outdoor air if you were to bring it inside the greenhouse and heat it up. So in this case, we have 50-degree outdoor air at 100% relative humidity. So picture west part of Washington State during the wintertime where it's raining, and a lot of people think that you can't grow a successful crop up there. However, if you operate your greenhouse properly, there's a great chance that you can, and we've seen that in practice. So if you were to take 50-degree outdoor air at 100% relative humidity and you were to increase it to 70 degrees using unit heaters or our radiant system and bring it into the greenhouse while you're simultaneously exhausting the moist air that's inside the greenhouse outside, the relative humidity would drop to 50% just by heating.
And that's because warm air can hold more moisture than cold air.
That's correct. And so a lot of people will tell you at this point, well, I'm worried about my CO2 concentrations going down inside my greenhouse because I'm exhausting air in the spring or in the winter months when I'm supposed to be sealed up. And sure, that is a possibility, but we have a solution for that. What we do is we add CO2 generators inside the greenhouse, which is designed to allow for 1 air exchange an hour and maintain a high level of CO2 inside the greenhouse.
You can also use CO2 generators first thing in the morning before it heats up outside in a warmer climate and add CO2 to your grow room that way.
That's a great point. So here's another example of dehumidification and venting. And so I want everyone to understand the process of ventilation. Ventilation exchanges moist, warm inside air with moist, cooler outside air. The process of heating up that air also reduces its humidity level. So bringing in outside cool, moist air into a greenhouse will reduce the humidity level, as Dave said. So here's a case where we have outdoor air that starts at 65 degrees Fahrenheit and 70% relative humidity. And when we heat it up in the greenhouse environment, 74 degrees Fahrenheit, it drops to 50% relative humidity. So there's certainly ways that you can maintain that low humidity level even in a high humid climate just by bringing in outdoor air and heating it up.
And again, the whole point is to keep it away from the dew point so we don't get any moisture condensing on the crop.
That's correct, and we're going to go into that in great detail. So one of the things that most folks will often quote us is that they're looking for a 50% relative humidity, which is really not a great indicator of fungal disease conditions. 50% relative humidity is an archaic way of thinking about your cooling system and your dehumidification system and your heating system back from the warehouse days of growing, where your warehouse would dump very cold air over top of the crop in a very localized spot just underneath the ductwork. And that would cause your plants to break out in powdery mildew and maybe even reach the dew point temperature and have fungal problems. And a great majority of this has to do with very poor mixing inside these warehouse environments and then poor controls for sensors. In a greenhouse environment, we think about it much differently because we mostly focus on condensation on the plant leaf. More important way of measuring this than using relative humidity is using vapor pressure deficit. VPD is independent of temperature. That's why it's such a great way of measuring the potential for disease. If the VPD is less than 0.2 kPa, condensation is likely to occur on the plant leaf and cause disease. The ideal range for VPD is between 0.45 and 1.25 kPa, with 0.85 kPa kilopascals being the ideal amount. And there's kind of a drawing off to the left-hand side that represents what this means. Vapor pressure deficit is an indicator of how easy it is for a plant to transpire, how much moisture there is in the air. If you look at the light blue dots, that's how much moisture there is in the air, and the dark blue dots is how much moisture is leaving the plant. And on the left-hand side, we have a high relative humidity, low vapor pressure deficit, meaning that the plant can't release moisture. And so you can see there's only 2 blue dots at the top getting away. On the right-hand side, there's a high vapor pressure deficit, which is a low humidity, and the plant can more easily transpire, and the blue dots can get away from the leaf, and there's less concern for disease.
So vapor pressure deficit is how easily water evaporates or how hard the water molecules in the air are pushing back against the leaf, which in turn affects how easily water can evaporate.
That's correct. So here's a chart that shows the differences in relative humidity if you keep the same vapor pressure deficit for a number of different temperatures. So as we mentioned, relative humidity varies by temperature, yet VPD remains unchanged. So at 50 degrees Celsius, the same VPD that would be necessary for disease outbreak, 0.03 psi or 0.2 kPa, would be about 83%. However, if you heat up that air, the vapor pressure deficit remains the same, and the relative humidity goes quite a bit higher too. So at 86 degrees Fahrenheit, the relative humidity needs to be about 95% at that boundary layer of that leaf for pathogens like botrytis or powdery mildew to set in. Then down below here we have a diagram of where the ideal VPD would be for growing given different relative humidities and temperatures. You can see at a temperature of 59 degrees, you absolutely want to keep your relative humidity below 50%. However, as you start to increase the temperature in the greenhouse up to 86 degrees, your relative humidity can climb up to about 80% before there's much concern for mold outbreaks. And then getting back to what Dave was saying, so talking about relative humidity, is how to control condensation inside the greenhouse. The most important thing to do is to minimize the amount of condensation on the plant leaf and keep the pathogens from initially setting in. Air movement is an important process for managing this. What we most commonly use are vertical airflow fans to gently move air around the plant, the entire canopy, and constantly move the moisture away from the surface layer of that plant leaf while the plant's transpiring, giving it a chance to transpire more and grow faster.
So the lower picture on the right is a picture of a vertical airflow fan. This is a fan that we actually brought over from other crops. I believe it was cucumbers, but it does a really good job at recirculating the air around the greenhouse, going underneath the canopy and pulling it back up through the canopy, breaking up that dead airspace at the crop level. It works really well, and it also recirculates your CO2 very well.
So when is humidity the largest concern? I tell most people to be most concerned with their humidity during the evening hours going into blackout. So blackout typically occurs from 7 p.m. to 7 a.m., but it might be shifted to 6 to 6, depending on what time of the year you're growing. On hot days when plants are transpiring, when going into blackout, say it's July and it's 7 p.m. in a northern climate, where it's really hot, those plants are still transpiring pretty heavily. So you want to make sure you close that blackout curtain very slowly, reduce the amount of light that's hitting that crop, give the greenhouse environment the chance to exchange some air outside, exhaust some air, and purge some moisture from the environment, and absolutely prevent the temperature from dropping quickly. As you saw with our psychometric charts, when the temperature drops, you have a higher chance of hitting that dew point and reaching a point where you have to worry about outbreaks of mold. Operate your mixing fans the entire time you're in blackout is a wise decision, and of course purge any humid air throughout the night with passive ventilation or mechanical ventilation that's available to you, and then heat the air in the winter times if necessary to prevent reaching the dew point.
Okay. Adding dehumidifiers is quite important, especially in areas of the country where there is high humidity. We work with several qualified vendors in order to provide dehumidification equipment. So regardless of the area of the country, we can put a greenhouse in each of the 50 states without humidity being a major concern.
One of the main points we were trying to cover here is you want to put your plants to bed slowly. You want to slow down that transpiration engine and hence prevent moisture buildup.
Now I'd like to move on to setting the greenhouse computer control system. So the computer control system controls everything from supplemental lighting, the shade curtains, the light deprivation or blackout curtains, the dehumidification fans, your inlet air, your mixing fans, your exhaust fans, your pad wall cooler, your heating, whether that be radiant heat or unit heaters, and supplemental CO2. So most greenhouses operate using a modern day controller, which you can access via the internet or your PC, and you can see real-time conditions inside the greenhouse and make adjustments remotely. Here are some examples of some different interfaces that are available with the different computer control systems that Nexus supplies. So I'm going to kind of start slowly and then work our way into different pieces of equipment, how we would operate them. The first piece of equipment that we didn't touch on very much is supplemental lighting. It's not necessary in every environment, but most cannabis growers prefer to use supplemental lighting so that they can maintain a high yield in the darkest months of the year. Typically, lighting comes in two different stages, and it's controlled based on light measurements and time of the day. So stage one is typically just 50% of your lights. So most guys will do what's called a checkerboard lighting pattern, where half the lights turn on at one stage and half the lights turn off at the second stage. LEDs have the option of being adjusted up and down, but most guys are still using conventional HPS lighting for cannabis production. So 50% of your lights turn on, and most often this happens whenever the light levels inside the greenhouse are less than 500 micromoles. Then stage 2 would turn on all the lights, so the remaining 50% of the lights, whenever the light level inside the greenhouse is less than 250 micromoles. So obviously 250 micromoles is quite a bit less light than 500 micromoles. So you might run stage 2 lighting all day long in the winter months, and you might run stage 1 lighting in the spring or fall just as bookends to increase light levels in the morning and evening hours of the greenhouse. Whenever the light levels are exceeding 750 micromoles, which is usually more than you'll ever see inside of a warehouse environment, but easy to hit using natural light levels inside the greenhouse, then all lights would turn off inside. And then also this controller will modulate the lights on and off based off of how much time they've been running so that you don't have short duty cycles. And they'll also turn lights off based on time of the day so that you don't have lights turning on in the blackout hours at night. Then you have a shade curtain system, which is controlled based on typically outdoor light levels. So if outdoor light levels start to exceed 750 watts per meter squared, the shade system will typically retract and try to maintain 600 watts per meter squared or less inside the greenhouse, which is really kind of the maximum amount of light that the plant wants to receive. And then, of course, these shade systems can be used at nighttime as a heat blanket as well.
Okay, keep in mind that by setting the greenhouse computer control system, you can maintain and make changes and monitor your control system remotely. So if you're on vacation, if you're traveling for business, you're seeing relatives or family, you have the peace of mind that you can make adjustments remotely.
The other thing, too, when you're talking about remotely controlling the system is these systems are set up with a light sensor called a pyranometer. And that actually will read the amount of daylight coming into your facility and either open or close shade curtains or turn on or off your lights automatically.
That's correct. So then going to the blackout curtain control, this is most often just based off of the time of day, basically a timer that's built into the controller. It typically closes for 12 hours a day, open for 12 hours a day. However, if you're growing in the city or you're growing in an environment where you can't allow for light pollution, these blackout curtains will close at sunset and open at sunrise to prevent outdoor light pollution. And if you're trying to maintain a longer photo period than the day allows, you would operate your supplemental lighting with the blackout curtain closed to achieve that longer photo period. Then you have your growing zone dehumidification fan. This is based on greenhouse temperature and humidity. This is stage 1 cooling. It usually turns on whenever the temperature exceeds 75 degrees inside the greenhouse, or if the relative humidity gets too high. Say, for example, it's nighttime and your temperature is in the 70-degree range, but your relative humidity is creeping up there. This fan will purge out the moist air and bring in fresh, low humidity outdoor air.
So the blackout curtains can actually be used to prevent light pollution if it's required by your local ordinance.
That's correct. Now getting back to cooling, which we've kind of already discussed a little bit here, your inlet shutters will open based off of whether or not you have your fans turned on or not. And so this also is true whether or not you have passive ventilation. Typically, if you have passive ventilation, you have some kind of form of inlet shutter. However, passive ventilation is less common in cannabis greenhouses than mechanical ventilation. Multi-stage, depending on the number of fans they're turning on. So once your exhaust fans turn on in stage 2 cooling, this is typically set just a little bit hotter than stage 1 cooling. It also runs stage 1 cooling simultaneously. So as we mentioned previously, stage 3 cooling, which is the pad wall cooler, it'll run with all the fans from stage 2, all the vents open from stage 2, and all the fans from stage 1, and all the vents open from stage 1. When we talk about dehumidification, this is controlled based on temperature and humidity. When outside conditions are favorable for growing, you can open up a passive house altogether and just let the outside air mix with the inside air to maintain temperature. So that's the most common form of operation when you're running a passive greenhouse because it doesn't use any power.
But outside air can also be drawn in on a mechanical greenhouse as well if that outside air has favorable conditions.
That's correct. So, say for example, you're in Colorado on a spring day, and the outside air conditions are 73 degrees and 35% relative humidity. You could run that air throughout the house the entire day and have a comfortable growing environment. Next, I'm going to move on to the stages of heating. These are based on greenhouse temperature. Stage 1, as we mentioned, could be in-slab heating, under bench heating, of course, to unit heaters. Most times, growers have different set points from day and night. Sometimes they'll have the night set point be a little cooler than the daytime set point. Typically, stage 1 heating turns on whenever the daytime temperature is less than, say, for example, 72 degrees, and whenever the nighttime temperature is less than, for example, 70 degrees. You don't want that temperature to be set too low because, as we mentioned, you don't want condensation to occur in places in the greenhouse. Stage 2 heating turns on simultaneously with stage 1. When stage 1 is not able to keep up with the demand for heat, it's a redundant system to give you backup on the coldest days of the year. And typically, it would be on if the temperature reaches below what the stage 1 set points were. So if stage 1 set points were 72 degrees, and it got down to 70 degrees inside the greenhouse, stage 2 heating would turn on, and we would have a similar thing happen at nighttime as well. If the set points were 70 degrees at nighttime, and it got down to 68, we'd have stage 2 heating turn on in conjunction with stage 1 heating already in place. Mixing fans in practice are almost always on, even when we're exhausting in the summertime. With typical greenhouses, you wouldn't do this, but with campus guys, they just tend to leave their mixing fans on all the time. If you have all your exhaust fans on inside the greenhouse and you're moving the air across that plant at 2 or 3 miles per hour, typically you wouldn't need that mixing fan, but they are extremely important during the nighttime hours, even if you are exhausted. And then supplemental CO2, as we mentioned earlier, is typically used to increase the concentration up to 1,000 ppm inside the greenhouse. It's typically turned off during times of year where you're exhausting massive amounts of air for cooling. And at that point, CO2 is really not limiting the growth of the plant because we have so much fresh CO2 coming past that plant at any given moment. So one of the questions we get asked all the time is, why do I need a warehouse space? And warehouse spaces are important for a number of different reasons. They provide you an opportunity for offices, locker rooms, trimming, drying, and curing, as well as your vaults. Some guys will have security rooms inside this, depending on which state they're operating in, and lobbies. Warehouse facilities are also used for extraction equipment, for labs, to make concentrates, or cartridge assembly, for packaging. Many times our customers will use the warehouse space to actually grow young plants in there or their mother plants. So sometimes we see it used for cloning because it's a gentle environment for young plants. And then, as we mentioned, you want to size your warehouse for the proper amount of greenhouse that you have. So a good rule of thumb is about 20%. We see people all over the range. In this case here, we have a 4,000 square foot warehouse and a 20,000 square foot total facility. One thing worth mentioning is that Nexus is a manufacturer of custom engineered buildings. We can supply that warehouse space to you and meet energy codes. It's easier to go with one manufacturer for the entire facility as opposed to having 2 different styles of construction, 2 different styles of tradesmen.
Yeah, and to keep the cost down, our warehouses are actually gutter connected to our greenhouses. So we have shared walls in common there, which you really don't have if you're going to go with an outside manufacturer for your warehouse space.
So the next question we get asked is, how much maintenance do these greenhouses take? And for the structure themselves, it's actually relatively simple. There's not much maintenance involved at all. Getting up and cleaning the gutters is one of the biggest pieces of work that you have to do for the greenhouses. And if you occasionally look at your cooling system, the different items you have to look at in your cooling system are your intake shutters. You'll have to occasionally clean those. Your shutter motors, you'll have to occasionally clean those and grease them as well. Exhaust fan motors, you'll occasionally want to look at those, make sure that their belts are tight, and the motor's in alignment with the fan. and that all the bearings are greased. Your vents, make sure that all rack and pinions are greased on a regular basis and in alignment where they're supposed to be. Always listen for any kind of noises that sound like it might be buckling or needing some grease, but these are pretty regular routine that really don't take a whole lot of time. It just becomes part of your everyday operations. And then you have your mixing fans, which occasionally you need to clean as well because they can get dusty. Your heating equipment, you have to look at your manufacturer's instructions, which we provide with the equipment that we supply. And on occasion, you'll want to grease the bearings and also clean the fans. So you'll do this before every major heating season. So in the fall, you'll kind of go through and you'll check on all your unit heaters and all your equipment. If you have a boiler system, you'll refer to the manual. Coverings are relatively simple. You'll wash them if needed. It's all dependent on the climate that you're in. No solvents are typically used. Most often it's just warm water and soap. You want to check for cracks in the attachments where they're attached and make sure none of the coverings coming up once a year. Your metal paneling can be pretty simply washed just with water and soap, non-abrasive cloth. Shade systems you always want to listen to just to make sure that you don't hear any loud buckling or any kind of indicators that you might need to grease your rack and pinion system.
You're listening for maybe stress on the motors at that point of the drive.
Exactly. Keep an eye on the drive system, see if it's having issues. Of course, all the motors come with set limits, so if they're being worked too hard, they would turn themselves off. So it's important to keep a watch on the shade cloth and the blackout curtain to make sure that it stays in alignment, but they tend to be pretty maintenance free. The fabric, you'll want to go into the blackout rooms on occasion and check for wears on the light depth fabric to keep any light leaks out, and make sure that the light depth fabric is also sealing tight against the flashing inside the greenhouse to keep light leaks out as well. It should be a regular occurrence every time you think about getting inside the greenhouses when they're light depth. Just check out what's going on there. And then your gears and motors, as we mentioned, just listen for them and check them every so many months based off of this chart here below. Your pad cooling system, depending on where you're located in the country, you might use your pad cooling system year-round. You might use it seasonally. If you're using it seasonally before turning it on every year, typically you have it locked out during parts of the year where it's really cold because you don't want any freezing to take place on the pad cooling system. And so before you start it back up in the summer or in the spring, just check it over, make sure the pump's clean, take out any debris. On occasion, you could replace the cellulose pads. More often than not, folks will put a algicide or some kind of sanitizer solvent inside their reservoir to clean the pads and get extra use out of them. And then light fixtures, on occasion you'll have to clean the reflectors and then walk through greenhouses and look for burned out bulbs. It's pretty standard. Whether folks from the warehouse environments will remember having to do this as well.
So to recap, with just a basic minimal amount of preventive maintenance, you can have a greenhouse that will grow excellent crops for a very long period of time.
That's correct. They're relatively low maintenance because, of course, they're industrial buildings. Then you have your equipment outside of the greenhouse. Most often I tell people to be mindful of their generators. You want to make sure you run your generators on a weekly basis if you have them, backup power. They're extremely important for maintaining temperatures in the greenhouse during extreme weather, and that tends to be when the power supply is not reliable from the grid. So every week you run for about 10 minutes and make sure our workers are around to hear them run. You also want to check to see if you have propane, if you're located where you need propane for heating or for electricity for your generators. You want to make sure those propane bottles get regularly checked and don't run out on you. And then you got your drip irrigation systems inside the greenhouses. These are relatively low maintenance, but you have to be mindful to keep cleaning the filters and to flush the lines here and there with solvents. If you're using organics, you'll have to flush the lines more commonly. once per cycle is recommended. And then you can use solvents such as hydrogen peroxide to do most cleaning. Most folks will have 2 drip emitters per pot, and so if a emitter should get clogged up, the plant's not starving for water for a few days, and you need to see the signs of that plant wilting, check that emitter and replace it if it is.
So one more thing about maintenance, and I just want to re-stress, it's very important to check those backup generators and to make sure your irrigation system is working properly, because those are the types of things that if they do fail during a power outage, then you could have catastrophic loss. So with this crop in particular, that can add up pretty quickly.
That's true. Almost anyone of size and scale operating in a greenhouse facility, let's say over 10,000 square feet, they would most likely have a backup generator. Then moving on to the insect screens. Insect screens very rarely ever get clogged with insects. It's mostly dirt and other fine particles that you see in the environment. Say, for example, if you're in an agriculture environment, there's a lot of dust being kicked up, or next to a road, there's a lot of dust being kicked up. You'll have to go through and you have to gently blow out the dust. Most often people do this with a backpack blower or a handheld leaf blower. Pollen can collect in there. So just be mindful that if the screens clog up too much, it's going to restrict air movement in the greenhouse, and it's going to be harder for it to cool itself.
So another thing, those screens are relatively cheap on a square foot basis, so you do replace them every once in a while.
Yeah, that's correct. People do replace them. Then regularly monitor your sensors for accuracy. So anytime you are in the greenhouse, take a look over at the aspirator, which is just another way of saying the sensor. It usually tells you the CO2 and the light levels and temperature and relative humidity. And if that piece of equipment burnt out for whatever reason, it's going to cause your controller to function improperly. So regularly monitor your sensors, and always carry a replacement aspirator circuit board in case one should burn out, because you don't want to have to wait to order one and have that greenhouse go without any kind of environmental controls for the amount of time it takes you to ship a new aspirator out to you.
Which is also a relatively inexpensive piece of equipment.
That's correct.
I want to thank you for attending the Webinar 5, Cannabis Greenhouse Operations Manual. And be sure to note